Hello everyone, let us work out question 7 coming from a 2023 grade 12 external math paper 2. So this question has got 3 parts and it is carrying 12 marks. Part A reads, the diagram shows the positions of 3 towns P, Q and R. PQ is equal to 7.1 kilometers, PR is equal to 23.8 kilometers, and angle RPQ is equal to 92.7 degrees. So this is our diagram showing PR as 23.8 kilometers, PQ as 7.1 kilometers, and the angle RPQ as 92.7 degrees. Calculate Roman numeral 1, distance RQ to 2 decimal places. So this part has 5 marks. Then Roman numeral 2, calculate the area of the triangle PQR. So this one has 2 marks. Then part 3, calculate the shortest distance of P from RQ, giving your answer to 2 decimal places. So let's work out the first part of A. Calculate the distance RQ to 2 decimal places. To work out distance RQ, so first of all we analyze the information we have here. PR is given as 23.8 kilometers and PQ is given as 7.1 kilometers, and we have angle RPQ which is 92.7 degrees. So we have one angle and 2 lengths given. And then if you notice, RQ, the distance that we want, is opposite to the angle given, which is 92.7 degrees. So for this we are going to use the cosine rule. So working with the cosine rule, we are going to denote the sides given using small letters. So the side RQ will be denoted by small letter P, and the side PQ will be denoted by small letter R, and the side PR will be denoted by small letter Q. So this is because these sides are opposite to the angles. So for example, if you look at the side RQ, it is opposite to angle P, which is a capital letter there, and the side PQ is opposite to the angle R, which is also a capital letter, and the side PR is opposite to the angle Q. So we use these denotations. So then the formula is going to be written as follows. So Roman numeral 1, P square is equal to Q square plus R square minus 2QR cos capital P. So capital P is the angle and these small letters are the sides. So then substituting what we've been given here, Q, on Q we're going to put 23.8 square, then plus, on R we are putting 7.1, so 7.1 square, then minus 2 times 23.8 times 7.1 cos 92.7 degrees. So P square is going to equal to, so when you add the squares, 23.8 square plus 7.1 square, this gives 616.85. And when you multiply negative 2 times 23.8 times 7.1 cos 92.7 degrees, this gives the positive 15.92. And then P square is equal to Addition of 616.85 plus 15.92 gives 632.77. Then to get P, we need to work out the square root. So we'll apply square root on both sides. Applying square root on both sides gives, so this square and the square root simplifies, giving us P is equal to, the square root of 632.77 is 25.1549191, and rounding off this to 2 decimal places, this gives 25.15, and this is in kilometers. So this is our value of P, which is RQ in this case. So now going to the next part, calculate the area of the triangle PQR. So for this part, we're going to use the formula. So Roman numeral 2, area is equal to 1 over 2 times, in this case we're going to use Q and R as our sides for this formula, then sine P. So the angle we're using is angle P. Then the next stage will be area is equal to, so we just have to substitute here. So substituting what we have on Q, we're saying this is 23.8, then times R 7.1, then sine, the angle is 92.7 degrees. So area is equal to, multiplying 1 over 2 times 23.8 times 7.1 sine 92.7 degrees gives 84.39620554, and then rounding off these two corrects to 3 significant figures. This will give us 84.4 square kilometers, and this is our area. So on area we are using 2 sides and 1 angle. Then going to Roman numeral 3, calculate the shortest distance of P from RQ, giving your answer correct to 2 decimal places. So for this part, what we are looking for here is a shortcut, a line that will connect RQ, the line RQ to P. So first of all, let's draw this line. So when we create a line from P joining the line RQ at the point, we can even put a point here at the point X here, then it means that this line XP is the height and the line RQ is the base, and we've come up with a right angled triangle. So at the point of intersection for the line PX and for the line RQ, we are forming a 90 degrees. So this means that we can use area of a right angled triangle to calculate for the height that is unknown here, and the base is known. RQ is the base, which we calculated as 25.15 kilometers. So for that we use the area of a right angled triangle. So Roman numeral 3, area is equal to 1 over 2 BH, and on area we're going to put 84.4, all this equal to 1 over 2 B, on B we're going to put 25.15 because that's our base, so times 25.15 and then H. So 2 is going to multiply with the 84.4 and this is going to give us 168.8. Then this is equal to 1 times 25.15 times H gives 25.15H. Dividing both sides by 25.15, this gives, on the right side, 25.15 into 25.15 gives 1, and 1 times H gives H equal to 25.15 into 168.8 gives 6.698412.698, and this can be rounded off to 2 decimal places as 6.70 kilometers. So this is our short distance of P from RQ. Then going to B, on B we've got the question: solve the equation 3 tan theta equal to 89 for theta ranging from 0 degrees to 180 degrees. So for this one, if you look at the range for theta, we are looking at the first quadrant and the second quadrant. And if you look at tan is positive in the first quadrant and negative in the second quadrant. So for theta that we are looking for here, we are specifically looking for the value of theta in the first quadrant. So finding the solution to B, so we're going to write B. So 3 tan theta equal to 89. So we're going to divide by 3 both sides. So dividing by 3, 3 into 3 is 1. 1 times tan theta gives tan theta equal to 89 over 3. And then finding theta, we apply tan inverse on the right side. So tan inverse of 89 over 3. This is going to give us theta equal to 88.1. So this is correct to 1 decimal place. For angles, we have to leave our answers correct to 1 decimal place. Then working out the last part, C, simplify 9x squared minus 1 over 9x plus 3. So for the top part, square root of 9 is 3 and 3 square is the same as 9. Then x square minus 1, and 1 square is the same as 1. So here on 1 we'll put a square, and then everything divided by, for the denominator here we can factorize 3. So factorizing 3, so we open bracket, 3 into 9x gives 3x, then plus 3 into 3 is a 1 there. So we close. Then the next stage is going to be, so 3 square x square can be written as 3x in brackets square, then minus 1 square, then everything over the same thing, 3 open bracket 3x plus 1. Then this will equal to, so since 3x in brackets square is subtracting with 1 square, this means that we are dealing with a difference of 2 squares. So this can be written as 3x plus 1 in brackets, then 3 3x minus 1 in brackets. So everything over 3 open bracket 3x plus 1. And what we can do here is just simplify. So 3x plus 1 can simplify with 3x plus 1. So 3x plus 1 into 3x plus 1, that is 1, and 3x plus 1 into 3x plus 1, that is also 1 there. And 1 times, on the numerator, 1 times 3x minus 1 gives 3x minus 1, then over 3 times 1 gives 3. So 3x minus 1 over 3 is our solution on the last part. So these are the answers to the 3 parts of this question 7 from a 2023 external paper 2. Thank you so much for watching this video.